This is lesson 9, and in this tutorial I'll be talking about the mixed columns. We've talked about the shift rows in lesson 8. So this is mixed column. You can get this the full tutorial at project Fpga/AES select mixed column. So this is the page on the website, project Fpga/AES mixed column advanced encryption system. You see the variable code for this chapter here also. Then also I'll be explaining this variable code in Logisim, so to give a clear picture of what the mixed column does. So this is circuit in Logisim. But before we jump into Logisim, let me briefly give a background of what it looks like. So in our last tutorial, this was what we used to explain the shift rule. So in this way, I'll be using this to explain the mixed columns. So for this, the mixed column, you do it for each of the blocks. So each of these blocks, we are going to repeat the same algorithm for it. So it involves multiplying each of the blocks with a fixed matrix. So this is the matrix here. We're going to multiply block A with this matrix, block B with this matrix, block C with this matrix, and block D with this matrix. So I'm going to do this just for only one block, and you repeat it for the rest of the block. I'll be using block A for this. So this is block A. I'm going to multiply it with this matrix. This is the usual matrix multiplication. So you select each of the blocks. So if I select block A, I'm going to use this A0 to multiply everything down here, and I'm going to use A1 to multiply everything here, and I'm going to use A2 to multiply everything here, and I'm going to use A3 to multiply everything here. So this is what I've done here. This is the A0 multiplying everything in the first column, A1, A2, and A3. Then at the end, you XOR everything. So the XOR is more like the addition we are using here. So we are going to XOR everything here, XOR every single thing here in the first row, and then we're going to get the new A0. So when we repeat this for B, we're going to get the new B0, B1, B2, B3. So this is how it works. So after doing it for A, you do it for B, you do it for C, you do it for D. Then you're going to get a whole entirely new columns for block A, B, C, and D. So that's a way of scrambling it. Scrambling. That's what we are doing. So scrambling the bits of data, that's the encryption, using a specified algorithm to scramble bits of data. So likewise in Logisim, I'll just be explaining one of the blocks, so you can see the same circuit for block A, block B, C, and D. So I'll be using just one block for this demonstration. I'll be using block A very much. So this is block A. Let me get into the picture so you can see it more. Block A. I think the zooming, I hope this zooming is okay. So I'll be explaining just this block, but just have it in mind that that's the same operation that's repeated for block B, C, and D. So in ASL, Boolean algebra, matrices, algebra multiplication and addition, we know that multiplying by 2 means shift left by 1. That's multiplying by 2. Then multiplying by 3 means shift left by 1 and XOR with the original input. Then multiplying by 1 means returning the actual input. So I'm going to use this particular place as a cross. Let me point this place here, so you see what I did here. So this 4 outputs here is what I describe as my multiplication by 1. I multiplied everything by 1. So multiplying by 1 means you are still going to get the same output. So this, for each of the segments, this is still the same output here, here untouched, here untouched, here untouched. So I can describe this place as multiplication by 1. Then I will now likewise describe this signal here as my multiplication by 2, because they are coming from here. So I told you earlier, multiplication by 2 means shift to the left by 1. This is it, where I shifted every single byte here by 1. Then it comes here. So this is, you when you go through the code, you see this particular section. It says when bit 1 of 7 is equal to 1, XOR it again with 1b. If not, retain our normal multiplication by 2. So the multiplication by 2 came out through this multiplexers here, then came down here. So I can use this signal as multiplication by 2. Then finally, okay, I want to do something. So here is my multiplication by 1, multiplication by 2, and here will be my multiplication by 3. So here, everything here in multiplication by 3. I told you multiplication by 3 is when you take multiplication by 2 and you XOR it with the initial input. That is, see here, this is the output of multiplication by 2, and then I XOR each of them with the actual input. So this is for A0, this is for first one, you XOR it back with the initial input. This one is XOR it with the initial input, this one initial input, and then this one initial input. So I can say that here is where my multiplication by 3 came out here. Yeah. So you can now go ahead to check our box and see where we are heading to. So I will go back to this drawing board. Let me remove this. So remember, we are going to XOR each of them. So we're going to have XOR 4 inputs for every row. We are going to XOR 4 inputs for every row. So that's why I have with me here a 4 input XOR gate for each of them. So this XOR gate, 4 inputs, 4 inputs, 4 inputs, 4 inputs. So let's start with this first one. So let's see what is involved for that one. So it says, so we are on this line here now. So it says 2 times A0. So let's go back here and see. A0 times multiplied by 2. This is where I multiply by 2. Remember, multiply by 2 is here. So A0 multiplied by 2 is here. A0 multiplied by 2 is A0 multiplied by 2. Yes. You can see A0 multiplied by 2 went into the first multiplexer. Okay, I've highlighted it. So let's check the next one. 3 multiplied A1. So let's go back here. So 3 multiplied A1 should be 3 multiplied A1. This is A1 here. See, this is 3 multiplied A1. So let me highlight it and know what I want to drop on. You can see it likewise went there. It went to the first multiplexer. Then again we have XOR again with 1 multiplied with A2. So 1 multiplied A2 means A2 left untouched, because multiplication by 1 means untouched. So A2 multiplied by 1 should be here, should be this signal here, because here is A1, no, A0, A1, A2. So let me highlight it and see if you want to first multiplexer. You can see went to the first multiplexer, and then finally we have this one here, A3 times 1 multiplied by 1. So remember that multiplication by 1 means leave it as it is. So that is A3 untouched. So this is A3 untouched. You can see it went to the first XOR for the first XOR 4 input XOR. So let's do the same for this second row. Remember, this second row is being represented by this second XOR input here. So let's see. It starts with 1 multiplied by A0, which is A0 left untouched. So A0 left untouched should be this one. You can see it went into this second multiplexer. Then again we have 2 multiply A1, 2 multiply A1, so multiplication by 2 came out here, so 2 is A1. So you can see, oh, 2 multiply A1. Oh, now I have made this mistake. Let me see again. Oh, there's an error here. Okay, so I think let me quickly fix this. There's an error around here. So this one is supposed to go, this one's supposed to go here, whereas this one will go here. Now I fixed this. I'm going to change it for the rest of the CQ since they're equally the same thing. So here is, you said 2 multiply A1 by 2. So this is A1 by 2, which is this one. Okay, let me highlight it for you. You see, it went to the second multiplexer. Then the next one says 3 multiply A2. So let's check 3 multiply A2. So it's A0, A1, A2. You see, it went to the second multiplexer. And then finally we have 1 multiply A1, which is, sorry, 1 multiply A3, which is A3 left untouched. So which is this one. You can see it likewise went to this second multiplexer. So this is how we get this second multiplexer. Sorry, the second XOR 4 input XOR gate. Sorry, I'm so much used to multiplexer all the while. So then I'll just do for the third column only, then I will go to the logic sim to develop code. So for the third one, it starts with A0 multiplied by 1, which is A0 left untouched. So A0 left untouched, which is here. You can see it went to the third one also. It went to the third XOR. Then you have 1 multiply A1. Let's see. That is A1 left untouched, which is this one. You can see went to the third multiplexer, to the third XOR gate also. Then 2 multiply A2. 2 multiply A2 multiplied by 2 should be this one. You can see. So likewise went to the third multiplexer. And finally we have 3 multiply A3. So 3 multiply A3 should be this one. You see, so we are appropriately correct for this. So this is how we do for the last one also. So please, I hope you understand this. You can send me an email if you still have an issue understanding it. This is the verilog code. This, you can see where we did the 4 input XOR gate for each of them. So this is it, the 4 input XOR gate. So the ones we did, where you see state means left multiplication by 1. State means multiplication by 1. Anywhere you see state, it means multiplication by 1. If you see state minus 2, it means multiplication by 2. State minus 3 means multiplication by 3. So they were using a typical copy of this, So for the first way, you will see minus 2 minus 3 state. So let's verify this. You see, minus 2 minus 3 state. So state means multiplication by 1. So let's go again. You see state minus 2 minus 3 state. State minus 2 minus 3 state. So when you go through the code, it's very easy. Ask me questions if you don't understand. So that's that. Go through it. It's very easy to and very easy to comprehend. So thanks for watching. Subscribe to my channel. Thank you.